Hello friends, the next kind of weak slot and filler structure that we are going to see now is frames. Okay, in my last tutorial videos, we had seen semantic net, and semantic net is nothing but it's a graphical representation of the knowledge. Frame is nothing but it is just a structured representation of the same semantic net. Okay, so frame is a collection of attributes called as slots and the associated values that describe some entity in the world, that is called as filler. Now I want you to have look at this semantic net. This is basically a semantic net representing a hotel and the room in the hotel. So you have a class called as hotel room, which is a subclass of another class called as room, right? Then hotel room has an object called as room number 2. Okay, please note this arrow direction has to be it's wrongly placed. Arrow direction should be from room number 2 towards hotel room. This is wrongly placed arrow. Okay, please note, please do the change. The direction of the arrow should be from room number towards hotel room. Okay, so room number 2 is an instance of hotel room, right? Now hotel room contains hotel chair and it contains hotel bed, and hotel chair, its location is room. So now it is very obvious that since room number 2 is an instance of hotel room, okay, it's obvious that since room number 2 is a hotel room, okay, it's obvious that hotel room number 2 will also have a hotel chair and it will have a hotel bed, and the location of hotel chair in the room number 2 is the room, because it is one of the rooms of general entity called as room. Now when you consider hotel chair class is a subclass of a superclass called as chair. Okay, and hotel chair has its own attribute. One is location, other one is sitting on. So hotel chair is used to sit. Use it sitting on. Now chair, which is a superclass of hotel chair, chair in general has legs which are equal to 4. Chair always have 4 legs, and chair, its height is usually 20 to 40 centimeters. So basically this is the semantic net which we have. Now let us see how to construct frame structure. Frame structure is nothing but it contains set of different frames. So what we are going to do is each of this node will be considered as a frame. Okay, just as an example, see hotel room. Now what is this hotel room? I'm actually talking about this particular node, hotel room. Now just see this hotel room, which is a class, how it is connected to how many other nodes. Hotel room is a room, correct? So is one of the attribute of hotel room. So I just write it in a structured way. Hotel room is a slot, room is a filler. Hotel room is a room. So this is a slot and a filler structure I was talking about. So is a slot, okay, attribute, and room is a filler or the value of the attribute, and there is a colon written. So when you write the same graphical thing, see, if you have noticed, hotel room contains only 3 attributes in that figure. One is a, contains and contains. Hotel room contains hotel bed, hotel room contains hotel chair. So this is one frame for hotel room. So for the node called as hotel room, there are only 3 attributes. One is contains, is a, and contains. Now please note that there is also a wrongly placed arrow here. So you might say that hotel room is also instance of room number 2. No, the arrow should be in the reverse direction. So actually room number 2 is an instance of hotel room. I have wrongly placed the arrow. Please make this note. So this is a semantic net, and for every node of the semantic net, one frame can be written. I'll go further. You see, the next frame that I have created is for hotel chair. Now you see the next node called as hotel chair in the semantic net. What are the attributes of hotel chair? First of all, hotel chair is a chair. Okay, so hotel chair is a chair. Other attributes of hotel chair is use. Hotel chair's use is is sitting on, right? So hotel chair, its use is sitting on. And the third attribute of hotel chair is the location. The hotel chair's location is the room. So hotel chair location is the room. So there are only three slots, or there are only three attributes, and these are the fillers or the values of the attribute. So this determines the frame for the hotel chair, right? So I have just shown an example of the only two nodes. One is frame structure for hotel room, frame for hotel room, frame for hotel chair. Similarly, you can also write frame for hotel bed, frame for room, room number 2, chair, sitting on, and all the other nodes that are there in the semantic net. So basically, what is a frame? Frame is just a structured way of representing the contents of your semantic net. Semantic net is a graphical way, whereas just an alternative to that is frame, is a structured way of representation. Okay, so you see here, similarly I will be writing frame structures for all remaining attributes, and that completes frame system for hotel room. So as you go on writing for all, that you get frame system for hotel room. Frame system for hotel room consists of frame structure for each of the slots, like hotel room, hotel chair, then you will have hotel bed, and so on. Is it clear? So this is something called as a frame. Now here is an example of a frame system that I have taken. Basically this is a baseball team. Okay, now see here, person is a mammal. You see every frame structure over here, person, adult male, ML baseball player, Jack Roberts, fielders, ML baseball team. Every frame structure over here has the first attribute either as is a or as an instance. So how do you know whether a particular frame system is a class or an instance? So you see here, person is a mammal. That means person has to be a subclass of a superclass called as mammal. So person cannot be an instance, it's a subclass, right? Similarly, adult male is a person. That means there is a class called as person, and adult male is just a subclass of the superclass called as person. Also, the ML baseball player is a subclass of a superclass called as adult male. So it itself is a class. Fielder is a ML baseball player. Again, since there is a relationship is always between class and its superclass. Okay, so fielder is also a subclass of a superclass called as baseball player, and so also ML baseball team, which is a subclass of a superclass called as team. But you consider this individual frame here. Jack Roberts is an instance of fielder. What it means is there is this subclass of a superclass called as ML baseball player. That subclass is called as fielder, and one of the instance or object of this fielder class is Jack Robert. So Jack Robert is an instance of fielder. So it's an object or it's an instance of a class called as fielder, which is written here. Fielder itself is a subclass of a superclass called as baseball player. Baseball player is a subclass of a superclass called as adult male, and adult male is a subclass of a superclass called as person. So I think you can visualize the hierarchy. Now there are few things that I want you all to see. Okay, now you see this class called as person class. It has another class attribute called as cardinality, class member called as cardinality. Cardinality is an attribute. It's a attribute with value, default value, that is this big value, right? So it's an attribute of person class itself. Now you see the next attribute that I've written here is handed, right? And there is a star that is marked here. Whenever the star is marked, it simply means that this particular slot is available for further inheritance by the subclass of this class or by the object of this class. Okay, so whenever there is star, it means this attribute or this slot can be inherited further by a subclass of this particular class or by an object of this particular class. Also, the default value of handed attribute is right. Whoever inherits this particular class called as person, for example, adult male is inheriting person, right? Adult male is inheriting person, and it is defining the cardinality as this. But this cardinality, okay, is it's a unique attribute of adult male class itself. It is not inherited, but handed attribute is inherited by the adult male. I have not written it here because it is obvious that handed is inherited by the adult male class. Now, if I want adult male class to change the filler value or filler value of the handed slot, okay, then I would have written it again here, handed equal to and the new value. But if I don't write it, it is obvious that adult male also has an attribute called as handed whose value is right. So this is a default value. If I want adult male class to change the value of handed to left, then I will have to again write it here and write the new value. The same concept that we follow in object orientation. Okay, now let's go to ML baseball player class. Okay, you see cardinality and ether, the first two attributes or first two slots cannot be inherited by the subclasses or the objects of this class because there is no star written here. But the next 1, 2, 3, 4, 5 attributes that I have here, they all can be inherited by the class or the object or instance that that is created of this particular class called as baseball player. Now baseball player, if you see, fielder is a subclass of a superclass called as ML baseball player. So this fielder class can inherit all these attributes of a baseball player class. Also, for the first three attributes, we have specified the default values: 6, 1, equal to handed, batting average. So when fielder class is going to inherit these values, it will inherit these values along these particular attributes along with the default values. Now, if fielder wants to modify one of these values, then only we'll have to write it here. Like for example, batting average. Okay, batting average is default value is 0.252. But fielder class, after inheriting this batting average, it is changing the default value to a specific value, that is 0.262, and that's why I have written it again. Other values like height is not written here, but it is obvious that it is inherited. Okay, so if you ask what is the height of a fielder, it will be 6, 1. Similarly, bats attribute I have not written here. Why? Because it is inheriting bats attribute along with its default value. The reason behind writing batting average here is that the default value, that is 0.25, is being modified with a new value, that is 0.262, user defined value. Similarly, team and uniform color, we have not supplied any default values to this. They are inherited by the fielder class. Are you getting this? Now you will realize this. Okay, now fielder class, which is a subclass of baseball player class, is in turn, you see, Jack Roberts is an object or instance of this fielder class. So all the attributes of fielder will be listed in the Jack Roberts class. Notice that there is a height, balls, batting average, team and uniform color. Out of all these values, only batting average is mentioned in the filler class. From where it got other values, team, uniform color and all other values, they are taken from here. Okay. Also, please note there is one extra value called as balls, right? Now balls, this attribute is not there in any of the classes. It means it's a unique value, or it's a slot of the instance called as Jack Roberts, its own instance. It has created a new slot and it has set the default value as right. Is it clear? So this is basically something called as a frame. Okay, so that's all for this particular video. In the next video we are going to see more about this frame structure. Thank you.